Special products. So this is already the second to the last special product. We usually use them when we want to make a shorter version to obtain the product of two different polynomials. So instead of doing the usual procedure, the long multiplication procedure through distributive property, we can obtain the result easily through special products. So this time, the given must be a binomial and a trinomial. But you have to be careful about this special product. Make sure that it really fits into the condition. So I made a checklist here for you to verify whether this special product is applicable or not. So as of now, the given is a plus b. That's our binomial. And our trinomial is a squared minus ab plus b squared. So the first checklist here, you have to make sure that the first term of the trinomial is the square of the first term of the binomial. So the first term of our binomial is an a. So the first term of a trinomial is actually the square of a. So this is a yes. The next checklist, the second term of the trinomial must be the opposite of the product of the terms of the binomial. So our first term in our binomial is a, then our the second term of our binomial is a b. So we get its product, a times b is ab. But since it's positive, it must be a negative in our second term, in our trinomial, which is a negative here. So that's a yes. Then finally, the last term of the trinomial must be the square of the second term of the binomial. The second term of our binomial is b, and the square of b is b squared. And that's our third term here, b squared. So positive b squared. So if that is a yes, all of the three conditions, um, it will be true to the given binomial and trinomial. That means that the product would just be the cube of the first term of the binomial plus, because it's a plus here in our binomial, then the cube of our second term of our binomial. So that's the shortcut. So if it is a minus, for example, a minus b, so it must be a squared, then it has to be plus here because it has to be opposite here. So minus, then this must be plus. So if this is a plus, then this is also a plus. Then that means that this special product is not applicable. So going back, the shortcut is to focus your attention in our binomial. Get the cube of the first term, which is a cube. Then copy the sign or the operation between our two terms in our binomial. So that's a minus in here. And then you get the cube of our second term of our binomial. So b cubed. So let's try an example. So which of the following can we apply the special product of binomial and trinomial? So we have three options here. And don't forget about the three checklist. So let's try to consider A first. Okay. First thing that we have to check would be the first term. The first term must be the square of the first term of the binomial. The first term of the binomial is x, and the square of the first term is x squared, which is the first term of the trinomial. So that's correct. Next, the second term of the trinomial must be the opposite of the product of the terms of the binomial. So first times the second term is positive 2xy. But looking at our second term here, it's a plus. And take note, it must be the opposite. Okay, the best way to remember it, if you look at this is a plus. This must also be the opposite to fit in the second condition. So it's already an x, so A is not an answer. So let's proceed to B. So in B, I think they have same given from A. So first condition is already okay. The second term, the second condition, same. It's both plus. So that means it's not anymore. Um, the special product that we have just discussed about product of binomial and trinomial is not applicable anymore. So let's proceed to C to check. So first, it's already okay because it's just same as the first two. Now, the product of the two terms, x times 2y is 2xy. This is a plus and this is a minus. So this is already a check. Then finally, you get the square of our second term, 2y. That's 4y squared, which is check. So that means the answer is C. Now let's try several examples. So let's try to find the product of the quantity of 3a minus 5 times the quantity of 9a squared plus 15a plus 25. So take note that this is a binomial. This is also a trinomial. So perhaps you might check whether the special product for product of binomial and trinomial will be applicable or not. So first, the first condition, focus your attention in the first term of the trinomial. It's the first condition. It must be the square of our first term in our binomial. So since the square of 3a is 9a squared, so this is okay. Next, the second term of our trinomial must be the product of our two terms here in our binomial, and it must be the opposite. So since 3a times negative 5, don't forget it must be the opposite, so perhaps you can multiply it with negative already. So negative 3a is negative 3a times negative 5 is positive 15a. And that's our second term here in our trinomial. So we're good. We're good so far. And lastly, since the third term of the trinomial must be the square of our second term in our first binomial. So looking at it, since the second term of our binomial is negative 5 and the square of it is 25, which is by the way the third term of our trinomial, so that means this special product is applicable. So all you need to do, focus your attention in our binomial, get the cube of the first term. Then since this is a minus, so this is a minus as well. Then get the cube of the second term. So the cube of 3a is 27a cubed. Then the cube of 5 times 5 times 5 is 125. And that's our final answer. Okay, let's have last example. The quantity of 7a plus 2b, that's our binomial. And Our trinomial is 49a squared minus 14ab plus 4b squared. So now check the condition whether um, the checklist for product of binomial and trinomial will fit in to the given. So first, the first term of a trinomial must be the square of the first term of our binomial. Since 7a, the square of 7a is 49a squared, so that would be fine as of the moment. Okay, second condition, okay, it must be the opposite of the product of our first and second term in our binomial. The result must be the same as our second term here in our trinomial. So it must be the opposite, so negative, of 7a times 2b. Okay, 7 is negative times 7a is negative 7a times 2b is negative 14ab. And that's the second term on our trinomial. So that's a yes. Then third, the third term of our trinomial must be the square of our second term in our binomial. So since the square of 2b is 4b squared, and that's the third term of trinomial, so that's a yes. So in short, the special product of binomial and trinomial is applicable in here. So you focus your attention in our binomial where the first term is 7a and the second term is 2b. So get the cube of 7a. Then don't forget this is a plus, so this is also a plus. Then get the cube of 2b, our second term. The cube of 7a is 343a cubed. Then the cube of 2b, 2 times 2 times 2 is 8b cubed. That's our answer. So supposedly this is already our last example, but I would like to give an extension. This is quite challenging. So let's try to verify whether the special product of binomial and trinomial would be applicable in here. Considering that the first term or the first polynomial given to us is a binomial and this is a trinomial. So let's try to check first the condition. So don't forget, first condition says that the square of the first term must be the first term of our trinomial. So let's check. So since we have 3x to the power of 2a as our first term, we get its square. So the square of 3 is 9 because it's 3 times 3, 9. Then don't forget the exponent of x is 2a. And we just have to multiply the 2a and the 2. So that will become 4a. And that's the first term. So that's okay. The second condition, it has to be the opposite sign of the product of our first and second term. So it must be the opposite. So from positive to negative. So negative times 3x to the power of 2a times y to the power of 2a. So this would be negative 3 x to the power of 2a and y to the power of 2a. You cannot combine them because they have different bases, x and y. And that's our second term. So that's a yes. And finally, the third term of our trinomial must be the square of our second term in our binomial. So since y to the power of 2a raised to a power of 2, in which it will result to y to the power of 4a. So that's a yes because the third term in our trinomial is y to the power of 4a. So to get the product, focus your attention in our binomial, where the first term must be, you have to get its cube. So 3x to the power of 2a. Then from the given is a plus, so plus as well here. Then y to the power of 2a must be raised to the power of 3. So we have two bases here, so you start with 3 cube. 3 cube is 27. Because 3 times 3 is 9. 9 times 3 is 27. Then x, multiply the 2a and the 3. 2a times 3 is 6a. Plus the y, the exponent is 2a, so we multiply it with 3. That's power rule from loss of exponent. 2a times 3 is 6a. And this is the final answer.